Thanks a lot for coming tonight. And what I thought that we would talk about is climate change and adapting to climate change and how that's related to resilience and sustainability. I was in the Obama administration in what's called the Office of Policy at EPA, which is an office where we are supposed to sort of envision what the policy of all of the EPA is going to be. And so I worked with Lisa Jackson pretty closely in doing that, along with many other advisors in her senior management, and worked a lot on climate change adaptation policy within the EPA and eventually within the rest of the Obama administration. So what I want to do is talk about that, but then also narrow it down to talk about what that means to local governments, because one of the offices I supervised was the Office of Sustainability, which is a small office within the EPA which has grant money, you know, for cities like New Orleans and other places that are interested in smart growth and other sorts of things. So what I'm going to do is I'm going to tell you a little bit about the impacts of climate change, which you may know about already. I'm going to tell you what the federal government is doing about climate change adaptation. The answer is a lot, but you probably don't hear it very much in the news. And then I'm going to tell you about a particular pilot project that I was involved in that tried to link the federal government with small towns in Iowa in order to develop sustainable practices that would defend some of those small towns and cities from the ravages of climate change. And there are a lot of things that we might be able to learn here in New Orleans. And if you're up for it till the end, I'm going to tell you a quick story, a quick Katrina story about something in the Ninth Ward that I bet you don't know about. So let me just sort of get started. One of the things that I have been working on in my spare time are books trying to figure out what the relationship is between disaster law and environmental law, and environmental sustainability for that matter too. And the answer is there are a lot of connections. And so I teach at Loyola a course on disaster law, which has a lot of environmental law in it, and actually have a course book, Disaster Law and Policy, which we're trying to introduce into law schools and into other graduate school programs and undergraduate programs. The idea is, and this is going to be a theme for what I talk about as we go, is that I think that disaster planners have a lot to learn from environmental policymakers. There's a lot about how you think about precaution and irreversible effects in the environmental sphere that can apply to the disaster planning sphere. And I also think that folks in the environmental area, including a lot of folks at EPA and other environmentally interested agencies and sub-agencies, I think those folks have a lot to learn from disaster planners about quick response, making decisions on the fly, and sharing information with the public. And so those are some of the things that I think about when I'm a bureaucrat, all right, or a law professor. What I think about a lot when I'm just a regular human being is this, right? This is your planet. And this is your planet on climate change. And the thing to understand about that is that when you lift up the hood and take a look, climate change is already affecting and is going to affect temperature, precipitation patterns, sea level rise, and extreme events. So to say it another way, because of climate change in the next 100 years for sure, it's going to be a lot hotter, a lot wetter, a lot weirder. And we have to start as local governments taking those things into consideration. Because what we'll find when we start thinking more deeply about it is that climate change is going to affect almost everything you care about. Whether it's culture, whether it's public health, marine biology, wetlands, how your food is produced, your forests, your infrastructure, everything. So to just take a look at it very quickly, and most of the images I'm going to show you actually come from a government report from 2009, which you can find online. It's just if you Google climate impacts, you'll get to it. The climate's been changing for the last 100 years. We know that, we can measure it. And so you can see in various parts of the country, some places are getting hotter faster than others in the last 100 years. And that's tricky because things change in different places. Different parts of the country are going to have to respond to different kinds of problems. You may have seen this in the news, those hardiness maps that gardeners use that come from the USDA. The climate zone maps have actually changed. They've actually moved. So people in garden centers and nurseries are actually stocking different kinds of plants based on different kinds of things. I have to throw out a political thing. The USDA was almost prevented from putting a map like this out because our representative, Steve Scalise of Louisiana, had proposed a bill that would have forbidden the USDA from taking climate science into account in doing any of its, in updating any of its programs, which is a little strange, right? If you're trying to make sure that your agriculture is productive, right? That your farmers are growing the things that are going to show good yield. Precipitation is changing too. It's a different story in different parts of the country. We're going to talk in a minute about Iowa, so I want you to just take a look sort of in that breadbasket area, right between 15% and 31% of increasing rain. A lot of that's heavy downpour, and heavy downpour creates floods, all right? We also know that these things are just going to keep going. So depending on what sorts of measures you use, what kind of emission assumptions you make, we're looking for anywhere in between a 2-degree rise Fahrenheit to an 11-degree rise Fahrenheit in the next 100 years. And that's compared to a Fahrenheit rise of 1.5 in the last 100 years. So look at it graphically, kind of interesting. Look who's going to be visiting Louisiana in the next 100 years. One of the things you can do is you can take a look here and start to see that the summers and precipitation patterns in Illinois, for instance, are going to be a much closer to this part of the country as we go. And so already there are state officials in the state departments of transportation that are talking to people in Texas to try to figure out how do you build roads when it's hotter, right? How do you have to put the roads together so it's more resilient in a hotter climate? What are the sorts of things that you do in terms of infrastructure that you prepare for hotter climates as opposed to lots of snow and ice and these sorts of things? At EPA, when I first started there, Lisa Jackson asked me to think about what the agency itself might do to prepare for climate change. And this was part of a larger steering committee that the president had actually put together, which I'll tell you a little bit more about. Now, in the beginning, I was talking to some folks who were saying, well, EPA's mission is to protect public health and the environment. We're just going to keep doing that. But as we kept thinking about it from office to office within the EPA, we realized that almost everything that we did was going to have to be geared toward climate trends. So for instance, EPA is very proud of air protection programs. But when summers get hotter, ozone seasons are going to get longer. And when ozone seasons get longer, smog standards set at the national level are going to be harder and in some cases impossible for some states to meet. So they're going to get fined. But they're not going to know what to do about it because it's sort of not in their control anymore. It's just because things are getting hotter or because the precipitation patterns are changing. In terms of water, we started looking at this, and if precipitation patterns start getting higher, sewer overflows are going to increase. Combined sewer overflows are going to increase. And so in particular in cities, you know, like Chicago or Detroit or New Orleans, you're going to expect more of these overflows. Those are public health related problems. And what the mayors are concerned about, and the governors of their states, is EPA fines cities if they have too many sewer overflows a year. And pretty soon, you know, some cities are going to be looking at increases of 10 times the number of sewer overflows they have unless they restructure their pipes and their water systems. So it's an infrastructure problem. On top of all of that, there are going to be issues with heat stress, issues with vector-borne disease. Allergies are going to drastically increase in some places, which are going to aggravate asthma problems and other respiratory problems. And so there are all kinds of issues that local governments are going to have to be thinking about, in addition to all the things that they already think about. Chicago is one of the cities that really is doing some of the best work in climate change adaptation right now. There's a woman named Joyce Coffey who is just in charge of the climate change adaptation programs in Chicago. And they worry about sewer overflows, but they also worry about things like this. They're worried that in 50 years' time or more, they're going to be seeing hundreds, maybe thousands of more deaths related to heat stress in their city every year if they don't find some way to either cool down the hot urban areas or to provide cooling centers or other kinds of air conditioning, these sorts of things. This is related to something we learned about in Katrina, which is an equation that, that I teach all my students when I teach environmental justice or when I teach disaster. And the equation is that hazard equals vulnerability times exposure. And so we've already looked at some of the exposures, but the thing that we have to realize is that when the people or the communities themselves are not as resilient, we're really looking at trouble. So here are just some maps I like to show. The more shaded areas in this map are counties that are disproportionately African American in the United States. And one thing you notice about that is they're all in the hurricane belt for the most part, right? So hurricane policy is, of course, urban policy, and it's, of course, an environmental and a disaster preparation issue, but it's also an African American issue. Here's another map. It's the same kind of counties, only this time this is disproportionately Latino populations in the United States. And as you can see, most of them are in this particular belt that is going to see the highest amount of temperature rise in the United States as a result. And so climate change is a Latino issue, as well as other sorts of issues. Also a Native American issue, because most of the Native American nations are there too. Oxfam America has been working with a sociologist named Susan Cutter, who's been experimenting with putting vulnerability maps together. We actually at EPA have some of this technology ourselves, and we're experimenting with ways that we might use it. But what this is, I mean, it looks like one of those cell phone maps, right? But if you look a little bit closer, what you see are there are actually two different layers of information that make up a map like this. And so what the folks at Oxfam have done is they've said, well, let's shade in counties, first of all, that have more exposure to things like floods, to high winds, to storm surge. And then let's look at counties that have high numbers of people we will classify as vulnerable, either because of age or because of race or because of income level or education level. And then let's put those two maps on top of each other. And what you start to see are places that are really, really in harm's way, both because of the exposure and the vulnerability. Now, there are issues with maps like these. They're not nearly as fine-grained as we need them. It's hard to do anything just with a county, information at the county level. But if you could go deeper, you could figure out more and more about the people that you need to be serving and paying attention to first. In Chicago, they're experimenting this a little bit with sewer overflows, trying to find out where people are exposed in terms of sewer overflows, and then what characteristics of those communities can we find out about, and that might tell us about where we should be directing grant money or other sorts of services. So if those are the impacts with climate change, what do you do about it? One of the things you do about it is you reduce greenhouse gases. That's what the policy people call mitigation. Another thing that you do about it is you try to adapt to the problems that you're already going to have, that you know you're going to have. The CO2 that goes up into the atmosphere, the methane, other things, some of that stays up in the atmosphere a very long time, 50 years, 100 years. Some of the CO2 that's warming our climate right now is CO2 I put in the atmosphere when I first got my, 77 Blazer when I was 16 years old, and it got 8 miles to the gallon, right? So we're locked in to a certain amount of this warming, no matter what we do. Adaptation, it has a few kinds of strategies. One is resistance. We do this, right? This is one of our newest efforts, the West Closure Complex, which has, I think, the largest, strongest pump system in the world of its kind down here, designed to resist. Resistance is not always futile. Sometimes it's a good idea. We can adjust, and there are lots of interesting ideas, interesting architectural ideas, interesting planning ideas about making your buildings, your structures more resilient. So this is a pilot project on the rooftop of City Hall in Chicago. EPA helped support some of this, and it's designed to see what rooftop garden effects have on the urban heat island. And one thing they're finding is that they actually reduce the temperature of that roof by 70 degrees in the summertime. It also collects a lot of water, and if you can collect the water and use it in the right places, you avoid runoff. So these are other kinds of things you might think about. One of the things that's really, really hard for us to think about and talk about is something that some of us are going to have to come to terms with, and that's retreat. This is a small town called the village of Kivalina on a peninsula in northwestern Alaska. It is being sucked up by the ocean. It used to be barricaded by ice that would form in the fall and protect it from northern storms. Now that ice doesn't come until much later, and so the beaches erode. And so those people that are living there need to move. The Army Corps has told them that. The trouble is they need up to $400 million to find a new place and move there. And they don't have the money. So what they're doing right now is they have sued a bunch of electric plants and a bunch of oil refineries in the United States for nuisance, claiming a tort. And that's still wending its way into the courts. It's been briefed before the Ninth Circuit, the appellate federal courts. And we'll see what happens with this. Sometimes adaptation doesn't go the way you think it is. I'm from Las Vegas, so I love new kinds of hotels. The Videra Hotel, a beautiful place, the first LEED certified hotel in Las Vegas, Nevada, designed to be cool as a cucumber inside, all right? But there was a problem. The parabolic shape of this mirror, honest to God, focuses the sun's rays at a particular part of the day, and it actually set a guy's hot hair on fire and melted a glass with a Mai Tai in it, okay? Plastic. So, you can't win for losing, but there are bad ways to adapt to. The thing that I think that environmentalists can teach disaster folks about, and also climate change adaptation planners, is the idea of a black swan, which is a term that economists use to explain low probability, high impact events. So Katrina was a black swan. Most of us didn't worry about something that big happening on any particular year, but you have to worry about these things. BP was a black swan. You can look in the environmental assessments and read language that the government approved in which BP says, for instance, we don't have to worry about large spills because they're rare. We don't have to worry about blowouts because they're rare. And it's like, oh, well, if it's rare, party, right? But the problem is black swans, because they're low probability, we do have to worry about. So I explain it to students this way. I say, look, you know, the way most people think about most things is that they fall on a bell curve. My students' grades fall on a bell curve. If we measured everybody's height in this room, it would probably fall on a bell curve. The size of cats, as it turns out, falls on a bell curve. And so if you were to look at all of the cats in the city of New Orleans, most of them would be near a medium size. And then there'd be a few outliers and a little kind of big ones and a little kind of small ones, and then that's it. The problem is hurricanes, earthquakes, blowouts don't occur on bell curves because there are too many interrelated feedback loops. This is scientific, right? You can show this with math. These sorts of events fall more on power curves, which are non-linear. And in fact, the reason the Richter scale is so confusing with earthquakes is because it's a power curve rather than a bell curve. So if cats, okay, fell on a power curve, it would look like this. You'd have lots and lots of little microscopic cats. And then there would be a few that were 2 or 3 inches tall. And then after a while, you know, maybe a long while, maybe, you know, through half of your life, you might see some cats that were 4 or 5 feet tall, all right? And then if you live long enough, you might turn around one day and see a cat like that, you know, 20 feet high, 40 feet high. Now, what's funny about this, right, is that you know this isn't real life. But when you start to think about issues that are low probability, high impact, things that almost seem impossible sometimes can happen, like blowouts or like massive hurricanes. And when you don't have the experience to know how big something has been in the past, it's really hard to predict. With Katrina, we had about 40 years of good studies about what hurricanes look like in this area. And so you could say, well, in the last 40 years, there haven't been very many that have been so huge. But when you only have 40 years, that doesn't tell you what the next 200, 300 years is going to look like. Well, when I first started in the administration in early 2010, Barack Obama had already, through executive order, created a special task force to look at climate change adaptation. And he put a steering committee together of several agencies, about 14 agencies, to come up with ideas toward a national strategy. I was on this committee representing EPA. And the things that we developed as we looked at this, talking to scientists and economists and environmentalists and people at FEMA, was that this is not just dour news, but it's essential to be resilient, healthy, and prosperous. It's like eating vegetables and exercising, right? You don't do all that to avoid just one kind of cancer. You do that because it's going to make you more resilient for everything, right? And we decided that that's what we wanted to do. We decided that we needed to think about international efforts and science, but the thing I want to concentrate on most here is this idea of being mainstream, making it our business all of the time to think about the climate. Farmers, for tens of thousands of years, right, have thought about the weather in thinking about what they do, farming, and we're at a point now where the dynamism of the climate is something that we're going to have to be paying attention to the way many of us pay attention to the weather, because it's a changing factor. Two of the principles we came out with that I'm very proud of, because my office tried very hard to make sure that they were championed, is to make sure that everything we do is integrated into other kinds of laws, including planning laws, and to make sure that we prioritize the most vulnerable, which is the other part of that equation of exposure times vulnerability. Now I'm going to drop a footnote. One of the things we were thinking about when we were on this committee is putting together some pilot projects. And we decided that we had to take some of the ideas that we had in this plan and try them out in real life and see if they would work. But how does a national government, the federal government in my case, help real people on the ground in a small town figure out what to do and how to have a lasting effect? So I started talking with some of my folks actually in the Smart Growth Office. We called it the Smart Growth Office, the Office of Sustainability. And a long time ago, when I was very foolish, I actually climbed this mountain, which was Mount Rainier. And a friend of mine was also someone who had climbed before. And so we started thinking, and we came up with terminology that I actually worked into a law review article. But essentially, the terminology has something to do with footholds and rope lines. And here's what I mean when a bureaucrat talks about footholds or rope lines. A foothold is something in the law that allows you to get a grasp and move forward toward a goal that isn't necessarily in the law. So we don't have a lot of statutes that say anything about adapting to climate change. Right? We probably won't have a lot of statutes in the near future that say a lot about adapting to climate change. But there are a lot of laws on the books which say things like make sure that communities are planned in a way to respect whatever hazards might come. Or there are statutes on the book that say make sure that the air is clean enough for people to breathe, or that there aren't a lot of sewer overflows. And what you can do is start taking those statutes, those footholds, and say that requires me to do research with climate change. Because if I don't take into consideration higher precipitation patterns, I don't get to protect against sewer overflows. You know? And so that's one of the ideas behind a foothold. The idea behind rope lines that we learned was that it really matters who is on your line. Okay, I learned this when I was mountain climbing. I mean, and you've got to have people who have different skills than you have, whom you can work with and communicate with, and who think differently than you think. And that was one of the problems with BP, frankly, is that when you have an agency in Department of Interior that's been looking at oil leases over and over again, and they read the language that says a blowout hasn't occurred and it's very rare, everybody nods their head and says, well, that's exactly right. That's what I've always been taught, you know. So you need somebody else on the rope to say, wait a minute, you know, that sounds crazy to me, or there's another way that this could happen. And so, you know, I'll talk a little bit more about that just in a second. The only thing I want to bring up, just to tell you a little bit about what we did in Iowa, just so you can see what the application might look like. Iowa is a place where there have been a lot of floods. All right. In fact, there have been 3 devastating floods in the last 17 years. And in fact, when we were looking for a place at EPA to decide how we might be able to try out some of our ideas, somebody in our Smart Growth Office said, we've got people on the ground who have been helping in Cedar Rapids and in Davenport and Iowa City because they're trying to recover from the 2008 floods. And so we said, okay, well, let's see what we can do. Let's look for a foothold of some kind. And so we started learning more about Cedar Rapids, Iowa. This flood was called the Katrina of Iowa. And it certainly in certain areas, I mean, you can see it was just devastating. Many people were injured. Many people lost their homes, displaced all kinds of families, millions of dollars in property damage. One of the things that people told me again and again in Iowa is how much livestock was lost. Thousands of pigs were swimming for their lives, and they had farmers on skiffs trying to pull the pigs onto the skiffs. And when the pigs got onto the levees, they would shoot them because they were afraid that the pigs were going to disrupt the structural integrity of the levees. So all of this kind of thing was going on. But here's the foothold we found, which I thought was really interesting. It turns out, hope against hope, right, that FEMA and EPA had recently entered a memorandum of understanding. 2 agencies that don't normally talk a lot to each other or work together, believe it or not. And here's what they agreed to do. What we knew about FEMA was that they help rebuild communities and they have a lot of money to do it. And we suggested to them, if you're in the business of rebuilding all of these communities and have money to do it, maybe you should incorporate smart growth, right? Because that's the time to do it, when you're rebuilding a community. And folks at FEMA said, oh, we hadn't thought about that. We don't know anything about smart growth. And so we said, well, we know something about smart growth. So we'll talk, right? And we'll help you spend your money, which is something at EPA we're very good at because we have a small budget compared to a lot of others. And then we got another idea. We said, well, as long as we're helping you incorporate smart growth, maybe we can help you promote climate change adaptation. Because you're going to be rebuilding levees, you're going to be putting your structures on new elevations, you're going to be deciding your flood maps again and what's at risk and what isn't. Wouldn't it be nice if you knew what the precipitation patterns were going to be? And so we started this dialogue and we identified some communities in which we already had connections with folks in Iowa. Iowa already had an infrastructure. They had rope lines called Rebuilding Iowa, the Rebuilding Iowa office. And it was a group of scientists. It had city planners involved. It had people who wrote hazard mitigation plans. It had politicians involved. And so we kind of dropped in and we had a series of meetings that I attended, the first and the last, and a lot of my staff went down in Iowa and just spent a lot of time down there. In fact, one of my staff said, he says, I could run for president. I've been in Iowa so long, and I've talked to so many real people, you know? And so we started to put meetings together of different folks, and we brought in some scientists to talk about climate change. And the first thing that happened, at least in one of my meetings, somebody said at EPA, "Oh, I know this great guy at MIT. We'll bring him down to Iowa City or to Des Moines and have him tell everybody about climate change." And then we thought, no, we're not going to do that. We're going to find climate scientists in state universities in Iowa who are on the ground and have been measuring the rivers to come in and talk. And what they said, they showed all their graphs and they said, you know what? The climate's been changing in Iowa. You know what? We have stream flow that's 20 to 30% higher than we've ever seen it, and there's no indication it's ever going to go away. And what that means is those 100-year storms, those 300-year storms that you've been seeing, they're going to keep coming. And we had everybody's attention. You know, some of them were into the climate change thing. Some of them didn't believe in climate change, but they're like, well, whatever it is, I don't want my house to be in that area. And so we started thinking about how we could incorporate climate change information into planning. And then one person on my staff who's wonderful, her name is Abby Hall, and she and I have written a little bit about this. She had this wonderful idea of another foothold. She said, do you know what? She said, FEMA encourages communities all over the country to write hazard mitigation plans. They have to write hazard mitigation plans that are approved by FEMA because if they do that, then they're eligible for funds when a flood occurs, something like that. She says, so you know what? Tens of thousands of small communities are writing hazard mitigation plans. Wouldn't it be interesting if we could get in on that action, right? And so we started to have conversations with FEMA about, well, could you help people when they write their hazard mitigation plans understand that it would be a good idea to put climate information in there? And at first, when we talked to people on the ground who wrote the plans, the consultants, they said, oh, we can't take climate into account. And I said, well, why not? And they said, well, because the regulations, according to FEMA, say that we can only use historical data to make the case for a hazard we're mitigating. And because the climate's changing, the historical data won't show that trend. Sounded a little weird to me, but everybody in the room said that was the case, including some local people who've worked at FEMA. So when I was back in DC, I talked to folks in DC about it. And I said, is this true? And we talked and talked and, you know, layer on layer. And basically what we found out is it wasn't true. that there were ways that you could take into account climate information without having to rely on history. But no one had ever done it before, and FEMA had never encouraged anyone to do it before. And you know how bureaucracy is. I mean, if you're writing a hazard mitigation plan, you're going to write it a way that it sails through the first time. You're not going to write it one way and then try to get it corrected. So we're still, I say we're, I'm not at EPA anymore, but the agencies are still trying to create situations where they can educate people that there might be other ways to write these hazard mitigation plans. And it would be really nice if government could find some money in order to push that. Because the one thing we found in all of this is local knowledge is extremely important. They know what's vulnerable. Local government is going to be implementing most of climate adaptation because it's all about water control and public safety and public health. And those are all local issues. But the other thing that they became convinced of is that only the federal government has the science for this. I mean, if you're talking about these massive computer programs that run the climate trends and this sort of thing, there has to be a way to generate that science, to make it available to people on the ground in terms they can understand, and that is information they can use in decision making, the way their laws are written, you see. And so there are all kinds of things that we can do, and we have a lot of money in the federal government too, and so the federal government might be able to use this money to help. One of the hardest things about this plan is that there are still, there's bickering in Washington, of course, and there have been not just Representative Scalise's bill, but there were a couple of bills last term that attempted to essentially tell, in one case the USDA and in another case FEMA, that they could not take climate change into account in adapting their programs. Extremely dangerous policy to tell FEMA not to think about climate change when they're developing strategies to prevent or respond to floods. So these are the things, these are the politics of it. But the locals, it seemed to me, they get it. And they understand the people to bring to the table in terms of these rope lines. Well, you've been so patient, and I've gone a little longer than I thought, but I promised you I would tell you a quick story about the lower Ninth Ward that you might not already know. All right, so here it is. That's the Ninth Ward about a year and a half after Katrina. A lot of you recognize it, okay? I don't know if anybody went to this event, but I did, and I thought it was so interesting that I wrote about it at the very end of my disaster book. But there were a number of folks at this time that were trying to generate some interest and also some civic engagement about climate change, and they wanted to do it through art. So one day, about a year and a half after Katrina, when the sun started to set, there was a huge display of tents, gumbo tents, Rebirth Brass Band. There was a sort of an outdoor stage with stadium seating around it, right at the crossroads of a particular desolate intersection. There were people playing music and singing, a lot of stuff that was free. Do you know what was going on? A group of people had decided to put on a play. There were some local actors involved, also some actors from the Classical Theater of Harlem, and they were going to put on a play that demonstrated some of the issues here. And the play that they put on was Waiting for Godot. I'm an English major, and there are not many times in life when art and life perfectly intersect, right? But to put on a 50-year-old play in which waiting was the common human experience was just enormously interesting. It was a beautiful production. Took up, of course, many themes. A lot of people I talked to, most people I talked to, everyone I talked to, thinks that Waiting for Godot was a downer, right? Because not much happens, and they're still muddling along. But whenever that happens, I think of a particular scene in which Vladimir in that play, who's a middle-aged black man, he tears off his dusty bowler hat and he roars just out into the night. And he says this, he says, "Let's not waste our time on idle discourse. Let's do something while we have the chance. Every day we're needed. at this place, at this moment in time, all mankind is us. So let's make the most of it, he says, before it's too late. And so the one thing that you braved the Mardi Gras parades to be here, the one thing that I want to ask you to do when you leave is to think about what chances you have and to make space for some creativity and action and to make the most of it before it's too late. Thanks very much.